All right, so we have our new Module 2 packet. Module 2, equations in one variable. Again, we should have already put our name first and last name on our packet. And then put our period number. And when you open up the packet, you'll notice the back side of this title page here is the same bell schedules. The packs are structured like the last one. Now it is bigger. I told you the last unit was a small review unit. There is some review in this unit, but then there is more we're moving on to. So we have our bell schedules. We get to our table of contents. 2-2, solving one-step equations. We are going to start that lesson today. So for the date, today is 9/5, so we should already be filling that in. And then we're staying on that page because we do need to add our essential questions. Our first essential question, what are inverse operations? Our second question, how do you solve equations? Question number 3, what does absolute value mean? So yes, we are doing some more work with absolute value this unit. And then our fourth question, how can writing and solving equations help you solve problems in the real world? All right, and we are again going to go to that first lesson starting on page 7, solving one-step equations. All right, so solving one-step equations, I know this is not new to you. This hopefully will be a refresher as we move on to solving multi-step equations in this unit. So to solve an equation, though, means to find all of the values of the variable that make the equation true. Solution, the value that makes an equation true. And equivalent equations are equations that have the same solution. Now, today we're only going to look at one part of solving one-step equations. We're going to look at the addition property of equality and the subtraction property of equality. And both of these are very similar because these operations are very similar. If a number is added to each side of a true equation, the resulting equivalent equation is also true. So we can add the same thing to each side without changing the meaning. Same thing for the subtraction property of equality. If a number is subtracted from each side of a true equation, the resulting equivalent equation is also true, so we can subtract the thing. Equations are all about being equal. They're all about being balanced. So the big idea there is if I add or subtract something from one side of the equation, to keep it in balance, I have to do the same thing on the other side. I can't add something to one side and not to the other. It will get out of balance. Equation, that equal sign is all about making sure that both sides have the same value all of the time. So that's the key here. All right, so again, what does it really mean when we're talking about the addition property and the subtraction property of equality? It means we're going to undo or use the inverse operation. So undo or use the inverse operation to solve. What is the inverse operation of addition? What is its opposite? Subtraction. What is the inverse operation of subtraction? Addition. So we undo by doing the opposite of what we see. If I see a problem has subtraction, that means I need to add. And the reason is because I need to get rid of whatever number is next to the variable. The whole goal in solving equations is to get the variable by itself. And I do that by moving everything away from the variable. So that is the goal here, is to get the variable by itself. So if I look at the first example here, g minus 25 equals 113. So again, the goal here is I need to have g by itself, which means I need to get rid of that minus 25. And how can I get rid of a minus 25? I can plus 25. Because minus 25 and plus 25 add up to 0. But if I'm going to plus 25 on the left side, I also have to make sure and go over to the other side of the equal sign and plus 25 as well. On the left-hand side, because that adds up to 0, it falls out of my equation, leaving me just g equals, what is 113 plus 25? So yes, we get g equals 138. Number 2, 27 plus k equals 30. Now again, the goal here is I want to get k by itself, so I need to move that 27. How can I move that 27? What is the inverse operation of 27? Negative 27 or subtract 27. Even though there's not a plus sign there, we know that the 27 is positive, so its inverse would be minus 27. And again, it has to go on the other side of the equal sign. So this 27 cancels itself out, and I get k equals, what is 30 minus 27? 3. So k has a value of 3. Number 3, a plus 26 equals 35. Again, our goal is we want to have a by itself to find out what it equals. So what is the inverse operation of plus 26? Minus 26. And again, if I do that on the left side of the equal sign, I have to do that on the right side. And I know some of you are going to say, these are so easy, do I have to show work? Absolutely. You need to get in the habit of showing your work. It's easy to show work because as we move on into the multi-step and the more difficult ones, we're going to need to make sure we're showing all of our work. So it's easy to start on these with showing our work. So a equals, what is 35 minus 26? Yeah, so we have a equals 9. Number 4, negative 4 plus t equals 7. What is the inverse operation of negative 4? Plus 4. And again, I have to make sure that is done to both sides. So t equals 11. And again, I know you have done one-step equations before. This is just to remind us what we are getting into. Remember about our inverse operations, so on and so forth. But obviously, it's not just about solving just equations that are given to us. On the next page, we have some word problems that we're going to work through. In tennis, the Grand Slam tournaments are the four most prestigious annual events. At one point in his career, Roger Federer had won 3 more Grand Slam singles titles than Rafael Nadal. If at that time Roger Federer held the record for the most Grand Slam singles titles with 17, how many Grand Slam singles titles had Rafael Nadal won? Does anybody know what the 4 Grand Slam tournaments in tennis are? One of them's happening right now in New York. The US Open. Big tennis tournament. It's on TV every day. The other 3 are Wimbledon, the French Open, and the Australian Open. Those are considered the 4 Grand Slam titles. All right, so how can we take this information? These word problems are a little different. They're not as where we just take the words straight out of the problem and translate them. It's a little tougher here. So the things we have, if we want to summarize what they tell us there, we have Roger Federer. I realized I should have made these boxes bigger. Won 3 more than Rafael Nadal. That's basically what this whole problem comes down to. Now, when you do the word problems on your homework, do you have to set up this whole chart? You don't have to. You can if it helps you. This chart is just to show you how the information is getting organized. So when you see these word problems on your homework, you have a way to attack them. So we need a variable. I'm going to say let n equal the number Rafael Nadal won. Because that's what they're asking me for, which means that's an unknown value. It says write an equation that represents the number of Grand Slam singles titles that Rafael Nadal had won. So that's our unknown. How many did he win? We know how many Roger Federer won. We're trying to figure out how many Rafael Nadal won. So how many titles did Roger Federer win? Yeah, Roger Federer had 17. So where his name is, we're going to replace that with 17. He won 17 titles. And I know it doesn't say equals anywhere in our problem, but where we have 17 equals, because we want to see, we want to compare the two. 3, what math does more than tell me to use? Addition, more than, so I'm going to be adding on to. And we said we're going to let n equal Rafael Nadal's wins. So the equation we just wrote is 17 equals 3 plus n. Could I have written it as 17 equals n plus 3? Yeah, addition can be done in any order, so reversing the n and the 3 here would not change the meaning of it. So if I want to find out what n is, what do I have to do here? I want to get n by itself, which means I have to move that 3. How can I move that 3? Subtracting 3. So 17 minus 3 is 14. So we have 14 equals n. Or you can reverse that and say n equals 14. They're the same thing. But what does that 14 represent? Yeah, so we would say Rafael Nadal won 14 titles. All right, number 6. On average, a male bulldog weighs 15 pounds less than a male golden retriever. If the average male bulldog weighs 50 pounds, write and solve an equation to find the average weight of a male golden retriever. Now, the next sentence has an error because they're asking us about the golden retriever. It should say, complete the table to write an equation that represents the average weight of a male, and it should not say, we know how much the bulldog weighs. It should say golden retriever there. So again, we need to take that paragraph and we need to condense it down to what it's saying. So basically, if we were to paraphrase this, we would say the bulldog weighs 15 less than golden retriever. We need a variable. We're talking about weight, so I'm going to say let W equal the weight of the golden retriever. Now, this one doesn't translate as well as the previous one when we were adding, because adding can be done in any order. Subtraction is very specific. You cannot just change around subtraction. So we have to pay attention to the wording here. How much does the bulldog weigh? The bulldog, they told us, bulldog weighs 50. We know the bulldog is 50, so that 50 is going to equal. Now, that 15 less than, that is not 15 minus the golden retriever. It is the golden retriever minus 15, because the bulldog weighs less than the golden retriever. So this would be W minus 15. So that is what we are solving. 50 equals W minus 15. we have to pay attention to those words. Less than means it has to be subtracted from. So it has to come after the other value. How can I undo or use the inverse operation here to find out what W equals? I have to add 15. The opposite of subtract is add. So we get 65 equals W, or again, you could write W equals 65. But again, what does that mean? It means that the average golden retriever weighs 65 pounds. Now, there is more to solving one-step equations, but we are just focusing on the adding and subtracting here. So we are going to stop this set of notes here.